All right, let's just dive right into one of those questions that's both completely terrifying and, absolutely fascinating. What would actually happen if our home, planet Earth, came face to face with a black hole?
So first things first, let's get some context. Black holes are not some super rare, exotic thing. Nope, our own galaxy, the Milky Way, is thought to have anywhere from 10 million to maybe even a billion of them. So they're a pretty common feature of our cosmic neighborhood, even if they are completely invisible.
And that's the scary part, right? Because they don't give off any light, we would probably never see one coming. We'd only realize it was there because of its gravitational pull on everything around it. So that raises the big question. What if one of these silent wanderers just happened to drift right into our path? Okay, so to really understand the danger here, we've got to clear up a massive misconception first. Let's talk about what a black hole isn't.
We all have this image of black holes as these cosmic vacuum cleaners, right? Just sucking up everything in sight. But that's not really how they work. They're just objects with a ridiculous amount of gravity in a very, very small space. Here's a thought experiment for you. If we could magically replace our sun with a black hole of the exact same mass, you know what would happen to Earth's orbit? Nothing. We'd keep circling it just like we do now. We'd freeze to death, for sure, but we wouldn't get sucked in. The danger isn't suction, it's all about how close you...
So, for our little thought experiment, let's bring our main character onto the stage. We're going to imagine a totally normal, run-of-the-mill black hole shows up. This one's about 5 times the mass of our sun, and just to put that into perspective for you, that is 1,650,000 times the mass of our entire planet. I mean, just try to wrap your head around that number. It's almost impossible.
And this is where it gets truly wild. All of that incredible mass, enough to outweigh our planet over 1.5 million times, is crushed down into a sphere that's only 30 kilometers across. That's the size of a city. The mind-bending density we're talking about here is just off the charts.
So, with an object this massive and this dense just hanging out nearby, what happens next? Well, its gravity starts to take a pretty catastrophic toll on our planet. The key idea we need to understand here is something called tidal forces. You see this on a small scale with our moon. Its gravity is what causes the ocean tides. But with the black hole, we're in a completely different league. The side of the Earth that's facing the black hole gets pulled with so much more force than the side facing away. And that huge difference in pull means the planet itself literally starts to stretch apart. The friction from this planetary deformation, would trigger earthquakes beyond anything we could ever measure. Volcanoes would erupt all over the globe, all at once. And pretty quickly, the entire surface of the Earth would just liquefy, turning into one giant planet-wide ocean of magma. And long before the planet itself totally breaks apart, everything on the surface, the atmosphere, the oceans, and all of us, we'd be the first to go, just peeled away and pulled right toward the black hole.
Okay, now we get to the climax of the story. As this mangled, molten Earth gets even closer, it goes through one final, very bizarre transformation.
At about 750 kilometers away from the center of the black hole, we cross the point of no return. At this distance, the black hole's tidal forces are now stronger than Earth's own gravity. The planet just can't hold itself together anymore. Starting from the side closest to the black hole, Earth's matter is stripped away, layer by layer, stretching our world into a long, thin stream of superheated plasma.
And yep, this incredible process has an equally incredible name: spaghettification. Some physicists even call it the noodle effect. Our entire planet, our home, is literally turned into a cosmic noodle. But the story doesn't quite end there. See, in its complete and total destruction, Earth creates something unexpectedly violent and kind of beautiful. So think about it. A black hole is the definition of darkness, right? It's an object so dense that its gravity traps absolutely everything, even light itself. So how on Earth could it create something beautiful? Well, that long cosmic noodle of what used to be Earth doesn't just fall straight in. Instead, it gets captured into orbit, forming this massive, swirling structure around the black hole. We call that an accretion disk. Just try to picture it. The very material that made up our world is now screaming around the black hole at thousands of kilometers per second. The friction in this cosmic traffic jam is just unimaginable, and it heats the gas up to millions of degrees. And the result? Our planet's remains start to glow with this unbelievable intensity, blasting out powerful X-rays into space. And here it is, the ultimate paradox. In its final, violent moments, the matter from our dark little planet being eaten by the darkest object imaginable creates a temporary beacon of light, one of the brightest phenomena in the entire cosmos. How wild is that?
So, Earth's story is over. But for the rest of our solar system, well, the horror is really just getting started. Over time, all that glowing material in the disk loses its energy and spirals inward. And one by one, the last atoms that were once our planet cross the event horizon, the black hole's point of no return, and they vanish from our universe forever.
Now with this new, supermassive object in our solar system, that delicate gravitational dance the planets have been doing for billions of years, it's completely shattered. Orbits become totally unstable. Planets could get sent crashing into each other. Some might get flung out into deep space, just wandering the darkness forever. The old order is gone, and it's replaced by a game of cosmic pinball, where the only outcomes are colliding, getting ejected, or falling into the sun or the black hole itself.
And that leads to a really chilling final thought, doesn't it? When you think about the absolute chaos that follows, the slow, violent dismantling of our entire solar system, maybe, just maybe, Earth's quick and fiery end was actually the most merciful fate of all. And all of this leaves us with one of the biggest unanswered questions in all of physics. When all that matter that was our world finally crosses the event horizon, is the information it contained, every person, every mountain, every single book ever written, is it all just erased from existence? Or could it somehow be preserved, maybe encoded on the surface of the black hole like a giant cosmic hologram? It's a mystery we just don't have the answer to. Not yet, anyway.